Alrighty, at this point in the adventure I've determined the frame thickness with a divider and a micrometer, measured the plug screw length I've needed, drilled and tapped both sides of the frame, marked the screws for easy reference during cutting, and then cut the screws. I decided a single slot drive would look best for this application and in keeping with the era of the gun's production, so I used a slot file, which is here, to cut the slots on the plug screws, then install the plugs, checking them for fit. I elected to adhere the plugs to the frame using solder in lieu of a Loctite product or welding. The Loctite products do not have the shear strength I feel is necessary and can break down when they come in contact with some of the modern solvents and oils. Welding would utilize a greater amount of heat than I feel is necessary. With frame wells that are only 4 millimeters thick, it could possibly distort the frame. The solders will melt and fuse at temperatures of between 450 and 600 degrees Fahrenheit, which will not affect the metallurgy of the frame, and they're also not affected by solvents or oils. They also have a shear strength of about 3 times the adhesives, plus most of the solders can be applied with a propane or a MAP gas torch, eliminating the need for super specialized heat sources. With these plugs now installed, I noted the detank cutouts are still visible on the left side of the frame, and I feel this would be out of place if I left it unattended. I've decided to install a second screw in the area. It's the one I'm going to use here, to clean up the cutouts and produce a look that is again in keeping with the era of this pistol's production. What I'm going to do is drill a hole right here, tap it, and install a screw, which will in essence look like a lock screw for the primary screw. This was normally done with a lot of machinery and firearms from this era, so it's not going to look out of place, and it's going to look a whole lot better than having these two little holes right here on the side of the frame. I've taken some measurements, and I've determined a 1/4 by 28 National Standard or American Standard screw is going to fill the area, not overwhelm the primary screw. I need to use a number 3 drill to make the hole for the screw, and then I'm going to use a 10 by 28 taper tap to go ahead and tap it out. Because this frame thickness back here is the same as up here, we got that 4 millimeter thickness. Using this size of a screw, I'm going to be able to get about 5 threads of bearing surface. So we're going to go ahead and do that and see how it turns out. You might note that I'm not showing any machinery or machining procedures in this video. I feel that if you're watching this and you choose to undertake this product, you're already going to have some machining experience in hand, and you don't really need to sit and bore yourself watching it being done. So I'm going to eliminate that. Plus, if I did all that, we'd have a video that's about 2.5 or 3 hours long. So let's see how this turns out. Okay, in this final section, I've gone ahead and made my my locking plug screw. Cut the slot. I went ahead and drilled my final hole with a number 3 drill. Tapped it with the 1/4 by 28 taper tap. Installed the screw for fit. Made the final fit adjustments. Screwed it into place. Soldered it down. Installed the grips. Polished these screws. And then I blued them just to try and match the original frame color as best as I could. I used a product right here for that. It's a liquid coal gun blue. Works just fine. Did a great job, actually, in my opinion. So now I want to cover some tips on doing this particular job. The first thing is, when you're drilling your holes, again, I strongly recommend you use a mill or a drill press, so you got a stable drilling platform. Second thing, when you're drilling the holes, I use a technique called peck drilling, where instead of just taking the drill and running it straight down and boring the hole, I will take the bit, and run it down in short steps like this. It's peck drilling. This way you're not going to catch the drill and break the drill, and it tends to produce a cleaner cut. You're moving those chips back up out of the hole. So it's just, I recommend it. It's especially important on this second locking screw here, because the first screws that we put in are quite hard. Peck drilling will allow this to cut through that screw material and do it clean and neat. The second thing that I did, this was a surprise here. I cut this side of this screw a little deeper than this side, and then when it's screwed in place, I put a steel block up here to support between the frame rails, and just tap this out using a cross pane hammer. Basically what it is, peened a piece of steel out over the outside edge of the gun. That in the retaining clip itself creates what's called a redundancy. This screw cannot, if the solder does break, the screw is not going to be able to turn itself into the frame. And the retaining clip here offers a bonus. It won't allow this screw to actually back out to the point where it's going to fall away from the gun. So the retaining clip in this will keep the screw from going 4F if the solder does break. That's an unlikely event, but it's a redundancy, not just the same. Same thing over here. This screw creates a redundancy for this screw. There's no way the primary screw can back out or go forward unless this screw here is removed. And the solder that I use is going to hold that in place really well. So, peck drilling, create a redundancy on your screws. When you're manufacturing or making your screws, your plugs, this is what a basic machine screw looks like. And prior to making your cut, you want to face this off up here using a screw plate. Just file that or sand it clean and flat with the screw plate so that the screw looks like this. If you leave this little tapered portion on, excuse me, this is to facilitate running a nut on, really allow for clearance in a blind hole. This little projection here is going to stick out into the inside of the frame, create some problems with the magazines hanging up in the frame. So in this case, we have everything clearance properly and the magazines are going to work correctly as they should. The solder that I used was it's a 95% tin and antimony mix. It already has the flux in it. You mix it up, you just stir it up, and it's a soft solder, so you can use a brush or a stick to apply it to the threads. Very good product for this. This melts at about 475 degrees. So again, it's not going to create any structural problems with the frame using this particular solder. And once you get everything done here, the last step is final assembly and then fit and function test of the gun. I hope this gives you a good stable idea for removing the safety on your Tokarev. One other thing, because these guns never had a safety on it to begin with, and you've effectively removed the safety, which I consider unnecessary and not of a good design. It really doesn't offer any major benefit to the gun other than to help get it imported into the United States. So, once this is removed, I would strongly recommend you carry the gun with an empty chamber instead of trying to carry the gun with a chamber round and either with the hammer down, half cock, or full cock. It's much safer to just leave the chamber empty while you're carrying the gun. Go ahead and chamber around when you're actually ready to fire. Just a little safety tip, and I strongly recommend you follow it. There you go. I hope this gives you a good idea for a little project. Thank you for watching.